Hello, so I'm Charlie McTernan and I'm a group leader here at the Crick Institute. And my group looks at how we can apply supramolecular principles in more biological settings. So how we can build molecular capsules and artificial molecular machines that can operate in biological environments.
Hi, I'm Manuel Miller. I'm a Sir Henry Dale Fellow at the Chemistry Department of King's College London. And my group is really interested in understanding how proteins are controlled by molecular on and off switches, so-called post-translational modifications.
And in this project, we are going to work together as two groups with different sets of skills to firstly build some macrocyclic compounds that are able to bind to targeted modifications on proteins. So a macrocycle is a ring, and we're then going to link sequence-specific amino acid residues off these rings. And we're hoping that will allow us to target specific modifications on proteins that change their function. So initially, you'll be working in my group to synthesize these hosts and to prove that they have differential binding between some of the interesting targets that we've identified. After this, you'll head to the Miller group,
where you'll get to explore the use of these potentially really powerful reagents to detect specifically modified isoforms, which will be useful in trying to understand how p53 integrates different signals and could maybe ultimately in the long run provide new avenues for diagnostics.
So, to tell you a little bit more about the specifics of the project. In supramolecular chemistry, we're very often inspired by the complex and functional molecules of biology. And in this case, we're really interested in the specific binding exhibited by proteins for their substrates. So these proteins are able to identify very specific substrates in a very complex and crowded milieu. And that's not really something we can achieve in synthetic systems up to date. So this project is really focused on finding ways to introduce this kind of specificity into artificial systems so we can monitor very specifically targeted guests in complex solutions. And that's not something we can do at the moment. To do this, well, we're going to use supramolecular systems called macrocycles. So these are rings of atoms with a defined internal cavity. And we can often trap molecules inside this defined internal cavity. And these are great, and they can bind a wide array of different molecules of different sizes, but they do have certain weaknesses. And that's that they don't really have much specificity. They'll simply bind to anything that fits inside the cavity. So this project looks at ways to add specificity to this already established binding. And how are we going to do this? Well, we're going to do this using some organic synthesis and also some of the sequence polymers of biology. Initially, we're going to look at using amino acid chains. So we're going to append amino acid chains to the exterior or periphery of these macrocyclic structures. And we're going to use this to program in specificity for certain functional groups. And why are we interested in these functional groups? Well, they are often expressed in proteins and change their function. And Manuel is going to talk a little bit more about that in a few moments. One word on what you'll be doing whilst you're with my group in the Crick. You'll be focusing on the organic synthesis aspects of this project. So you'll be looking at synthesizing these macrocycles and also specific amino acid chains. And this will be sped up by the fact that we have a dedicated and automated peptide synthesizer in the lab that you'll be able to use. So you'll be able to make rapid progress with this aspect of the project. You'll also gain skills in organic synthesis, NMR spectroscopy, mass spectrometry, and hopefully some X-ray crystallography. So you'll gain a wide array of very useful skills. So what are we going to do with these molecules once we've made them and shown that they bind to certain functional groups? Well, that's where our collaboration comes in.
And the target you'd be working is a protein called p53. And this protein functions as a really important tumor suppressor that prevents the accumulation of damaged cells and thus plays a really important role in preventing the onset of cancer. And accordingly, it's been mutated in about half of all known human cancers. So it's really important that we understand how this protein works and find new ways of how to reinstate its function when it's lost. And so the project here is to design macrocycles that will specifically recognize isoforms of p53, for example, those that are shown here, which carry specific phosphoryl groups, which represent individual activation steps that enhance its activity. And the goal would be to try to find macrocycles that can not only recognize specific phospho-p53, but also distinguish different isoforms which carry phosphoryl groups in different sites, which in turn have different biological implications. And so what you'd learn in my group is peptide synthesis of phosphopeptides ideally also the synthesis of entire phospho-P53, which we've done before, and use biochemical and biophysical means to measure binding of these phosphoproteins to your macrocycles.
And so before we wrap up, a quick word about both of our groups that you'll be working in. So I started my group in February 2021, and from this autumn will consist of 2 postdocs, Ellen and Javed. We'll have 2 PhDs, Ben and Karen, who'll be a year ahead of you, and also a lab technician, Hyen. So we all work on relatively similar areas. We look at how we can apply supermolecular chemistry in biological contexts, and we work in the Francis Crick building, which is pictured here and is right by King's Cross train station, so it's very easy to get to come and visit us. So if you'd like to hear any more information about the project or my group, please check my website and reach out to us both after this.
And my lab is based at Britannia House, where the chemistry department of King's College London is situated, really close to London Bridge, so also very nice and easy to reach. My lab consists of PhD students and postdocs who all share a fascination for post-translational modifications, both in biomedically important systems, but also on fundamentally interesting new types of post-translational modifications.
Perfect. And we hope you look forward to joining us and to hearing from you so we can talk more about the project.